Right. Good evening, guys. So today we start tutorial sheet 2. We are done with the questions from tutorial sheet 1. If you didn't see the video, it's there on the website. You can access the video. We solved all the questions in tutorial sheet 1. So today we begin this tutorial sheet 2 here. So we are starting first of all with some definitions here. So let's start from question 1. So on question 1 there, what we have is they're saying define and briefly explain with examples each of the following. Okay. So number 1, we have measures of central tendency. And then number 2, we have measures of dispersion. And then 3, we have measures of what? Position. So what are these measures of central tendency? I mean, the first one there. What are the measures of central tendency? Okay. So a measure of central tendency, maybe I should be writing, a measure of central tendency, I'll just put CT, okay, describes a central or typical value in a data set. Okay. So this is what we call as a central, a measure of central tendency. It's just a value that describes, or we can say the center of a measure of central tendency describes a value, okay, that is in the center, or it is a certain position in the data set. Okay. So just say center of measure tendency describes a central or typical value in a data set. So we have three central measures of central tendency. Okay, we have three of them. So the first one is the mean. Okay, so the mean, we know what the mean is. So the mean is just the average of the values, okay, that you have been given in the data set. So how do you find the mean? You add all the values that you've been given, and then you divide by how many they are. Okay, so this is the first measure of central tendency, the mean. Okay, and then the second one is the median. So the median is just the middle value in a data set. Okay, so when you arrange your data set in increasing order, the middle value is what we refer to as the median. Okay, and then number 3, we have mode. Okay, so mode is the third measure of central tendency. So mode is just the value that appears most frequently. Okay, so when you're given a data set, if you have one value, okay, it can even be two values that are appearing more than the other values. We call that as the mode. So it's appearing more than all the other values in that data set. So it has the highest frequency. We call it as the mode. So this is the definition of measures of what? Central tendency. And then from there, we can define the measures of dispersion. Okay, so the measures of dispersion, we also have some examples of them. So number 2, we are looking at measures of dispersion like that. So what are these measures of dispersion? Okay, or what do these measures of dispersion describe? Okay, so you're going to say that the measures of dispersion, okay, describes how spread, okay, how spread out or scattered, you can say, or scattered the data is. Okay, so that's what measures of dispersion are. They just describe how spread out, okay, or scattered the data is. Okay, so to give example of these measures of dispersion, we have about 4 of them, okay, the common ones. The first one is the range, okay? So this range is just the difference between the maximum value in the data set minus the minimum value. That's what gives you the range, okay? And then the other measure of dispersion is the variance, okay? Is the variance. So the average, the variance is just the average of the squared differences from the mean. Okay, so average of squared differences from the mean. Okay, differences from the mean. So its formula depends on if its formula depends on whether the data that you've been given is grouped or it's not grouped. Okay, so if it's not grouped, it has a different formula, and then if it's grouped, it also has a different formula. Okay, so we're going to see their formulas when you start solving some questions. And then the other one is the standard deviation, the SD. Okay, so the SD is just the square root. Okay, it's just the square root of the variance. That's what the standard deviation is, just the square root of the variance. And then we can also have what we call as the interquartile range. We can also give us an example of measures of dispersion. So the interquartile range is the difference, okay, between the third quartile, which we represent as Q3, minus the first quartile, which is Q1. Okay, so this Q1 is just the average of the first half of your data set when you arrange it in order. And then the Q3 will be the average of the second half of your data set. Okay, so these are some of the examples that we can give under measures of what? Dispersion. And then we can now talk about the measures of position. Okay, so what do we have on the measures of position? So number 3, we have measures of position. Okay, so what are these measures of position here? Okay, so a measure of position, okay, is just a value that helps us determine where a particular value stands within a what? A data set. Okay, so a measure of position, okay, determines, we're going to say this determines where a particular value stands in the data set. Okay, a particular value stands in a data set. Okay, so that's what these measures of position do. Okay, so an example of these measures of position is the quartiles. Okay, so the quartiles, we have Q1, I've explained what it was. We have Q2, and then Q3, I also explained what Q3 was. So this Q2 here is the same as the median. Okay, the Q2 is just the median. And then another example is what we call as percentiles. Okay, so these percentiles, they are examples of measures of what? Position. And then another example is what we call as the deciles. Okay, I don't think you at Apex you do the deciles. I don't know, maybe you do. Okay, but the percentiles and the quartiles, you will do that. All right. So these are the examples of some of the measures of what? Position. So that was question 1. We're done with question 1. We go to the solving part now. So here we have been given 2 different data sets, and then we are asked to find the mean, the median, the mode, the interquartile range, the mean deviation, the standard deviation, and the coefficient of what? Variation. So I'm just going to use one of these data sets, okay, to illustrate to you how to go about it. So let me say I pick this second data set here. So let's find the mean, the median, the mode, the interquartile range, the mean deviation, standard deviation, the coefficient of friction for this data set. And then once we do this, it means you can also do that, okay? It will just be the same procedure that we're going to follow. So let's first of all find the mean. Okay, so the mean is represented by x bar, and it is equals to the summation of all the xi's, okay, divided by how many there are, which is n. So this xi simply means these values that we can see in this data set that we've picked. Okay, so all of them. So summation means we are adding all of them. So 40 plus 40 plus 40 plus 60 plus 65 plus 65, and then plus 70 plus 70 plus 75 plus 75 plus 80 plus 85 plus 90 plus 90, and then plus 100. So we divide by how many they are. So how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15. So I'm going to divide by 15. Okay, so this is going to give me what? So you just get your calculator and then punch in all these values. So 40 plus 40 plus 40 plus 60 plus 65 plus 65 plus 70 plus 70 plus what do you have there? 75 plus another 75 plus 80 plus 85 plus 90 plus 90 plus 100. Okay, so when I get the sum there, I'm getting 1045. Okay, so counter check with your own calculators as well. So my calculator is giving me 1045 there, and then I divide it by 15. So this is going to be equals to, so divide by 15. Okay, so 1045 divided by 15. I'm getting 69.66667. Okay, so this one here is going to be our mean. So we're going to say our mean is just we can even round it off and say it's 70. Okay, but if you don't want to round it off, just say it's 69.67. So this one here is our mean. So I'm going to write it there. So the mean is 69.67. Okay, so that's how we find the mean. Okay, and then how do we find the uh, the median. Okay, so the median, you need to arrange your data in ascending order. So we see that our data that we have here is already arranged in ascending order. Okay, so the median is the middle value. So you start canceling. If I cancel this one, I cancel this one, cancel this, cancel that, cancel this, cancel that, cancel that, cancel this. Okay, so I cancel this one, cancel that one, cancel this, cancel that, cancel this, cancel that. So I'm only remaining with what? 70. So it means the median is 70. So median, so that's going to be equals to what? 70. All right, and then from there we can find the okay. So let me remove this to my arrows on this. Okay, so from there we can find the the mode now. Okay, so we found the median was
Oh, so
70.
just a minute. The numbers were 16 instead of 15.
They were 16.
Yes.
Okay, I see. All right, so okay, so what was the total that we found? So we said mean was equals to, so the total we had found 1045. So let me count the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I've missed some number there. Which number have I missed? 65, 75, 75. Okay, on the 75s here. There are 3 75s. I wrote 2. So it means somewhere here I have to say 75 plus. Okay, so it means even the total there is going to change. Okay, so when I had those 15 values, they gave me 1045 and then plus another 75. It's giving me 1120. So it means the mean now will be 1120, then divided by 16. So this is going to give me what? Okay, so 1120 divided by 16. Oh, okay, it's giving me exactly 70 there. Okay, so it means our mean is 70. Okay, thank you for that correction. I didn't see it. Okay, so it means even the median is going to change. Okay, even the median is going to change because now we have 16 data points. Okay, so it means if we divide this, we are going to get 8 values in the first half. Okay, and then 8 values in the second half. So let's just count to where we have the 8th value. So 1, 2, 3, 4, 5, 6, 7, 8. So we have this one there, or number 8. And then when we start counting from the last value, 1, 2, 3, 4, 5, 6, oh, 1, 2, 3, 4, 5, 6, 7, 8. So this is the 8th value. So this one is a data set that has uh, an even number of entries. Okay, so it means the median, okay, is going to be a value that will be between these two values here that are on the middle. Okay, so we're going to say 70 plus 75 and then divided by 2. So that gives me 70 plus 75. Okay, when I add them, it give me 145 and then divided by 2. I'm finding my median as 72.5. Okay, so that 72.5 will be somewhere here in between. So that will be our median or our what? Our Q2. Okay, so I can write it as 72.5. It's going to be on the middle there. And then we can now go to the mode. So the mode is the value that is appearing most frequently. Okay, so for the 40s, we have 3 of them. 1, 2, 3. Do we have any other entries that are 3? Okay, 65 we have 2, 70 we have 2, 75 we also have 3. Yes. Okay, so it means this data set has 2 modes. Okay, it's bimodal. It has 2 modes. So we're going to say mode. So that's going to be equals to 40 and 70. 70, is it 75? Not 70, 75. Because this 75 is appearing 3 times. Even this 40 is appearing 3 times. Okay, so that is our mode. So our mode, we have 2 of them. So it means this data set here is bimodal. Okay, what about the interquartile range? So interquartile range, we said it's Q3 minus Q1. Okay, so here we already found our Q2. So it means for us to find the Q1, we're just going to use this first half from this 40 all the way up to this 70. And then for us to find the Q3, we're going to use the second half from this 75 all the way up to what? To the 100. So what is the middle value of this first part here? This part here, what is the middle value of this first part? So we have 8 values there. So it means we are going to have 2 values in the middle. Okay, if we do the canceling, I cancel this with that one, this with that one, this with that one, I'm going to remain with 60 and 65. So it means my Q1 will just be 60 plus 65 and then divided by 2. So this is going to give me what? So 60 plus 65 divided by 2. Okay, it's given me 62.5. And then for the Q3, okay, even it's because it will have 8 entries, it means on the mid, we are going to have 2 values. So if I cancel this 75, I cancel the 100, cancel this 75, cancel the 90, cancel this 75, cancel the 90. So I'm going to remain with what? 85 and 80. So this will be equals to 80 plus 85 divided by 2. So what will this give us? Okay, so 80 plus 85 divided by 2. Hey, what's happening? 80 plus 85, then divide by 2. I'm going to get 82.5. Okay, so it means my Q1 is this and my Q3 is that. So we can find the interquartile range. So the interquartile range will just be Q3, which is 82.5, minus Q1, which is 62.5. So when we subtract these, what are we going to get? 82.5 minus 62.5. So I'm going to get 20. Okay, so 20 is our interquartile range. Okay, so found the interquartile range there. And then the other thing that we have to find is the mean deviation, standard deviation, and the coefficient of variation. Okay, so let's get the formulas for these guys. Okay, so we start with the mean deviation. Okay, so the mean deviation is given by the summation of the absolute value of all the xi minus the mean, okay, and then divided by the sample size, which is just 16 there. So we indicate that by n. So it means we have to find the difference between each of these data points that we have there with the what? With the mean. Okay, so the mean is 70, and then we have to find the difference with each of these data points there. Okay, so what we are going to do is we are going to come up with a table. Okay, for easy calculation, we're going to come up with a table. So I can erase this. Okay, so I'm going to come up with a table here. So, okay, well, how should I write it? Okay, let me write it in this form. So, okay, let me put the x there, okay, or the xi, and then here I'm going to put xi minus the mean, and then down, I'm just going to put xi minus the mean in modulus like that. So this is the table that I'm going to draw up. Okay, so if I have the value 40 there, okay, and then I also have 40, I don't know if this is going to fit. Okay, let me draw it a little bit bigger. Okay, let me get a straight line first of all here. Okay, and then we have such. Okay, and then let's put xi there. And then here we're going to put xi minus x bar. And then there we're going to put modulus of xi minus x bar. All right, and then from there we can start now putting these values here. So I have 40, 40, 60. Oh, I've missed another 40. So 40, 40, 60, 65, 65, 70, 70, 75, 75, 75. And then we have 80, 85, 90, 90, and then 100. Okay, I hope they have all there. And then here on this row below this 40, I'm going to put this 40 minus the mean. So remember the mean is 70. So what is it? 40 minus 70? It's going to give me minus 30, right? Okay, so it means the modulus of that is just 30. Here it is the same, minus 30, minus 30. The modulus of that is 30, 30. And then here it's 60 minus 70. 60 minus 70 is 10, minus 10. Then there to be 10. There to be 65 minus 70, which will just be minus 5. There to be 5. There minus 5, there 5. And then 70 minus 70 is 0, 0. Even here is 0, 0. Then 75 minus 70, we're going to get what? We're going to get 5. Even there to be 5, 5, 5, 5, 5. Then here to be 80 minus 70, which will just be 10. Then there to be 10. 85 minus 70 to be 15. here 15, then 90 minus that to be 20, 20, 90 to be 20, 20. Okay, and then 100 to be 30, and then 30. So these values now here that we have in this third row are the ones that we're interested in, because I said the mean deviation, okay, its formula was just what? The modulus, the summation of the modulus of xi minus x bar, and then divided by what? N. So here we just have to find the summation of all these values in this row. So let's add 30 plus 30 plus 30 plus 10 plus 5 plus 5 plus 0 plus 0 plus 5 plus 5 plus 5 plus 10 plus 15 plus 20 plus 20 and then plus 30. Okay, I hope you are also counter checking on your calculator. So this is giving me 220, then divided by how many are these ones? They are 16. So we're going to divide by 16. So the mean deviation will just be 220 divided by 16. So that one is giving me 13.75. All right, so any questions there on how to find the mean deviation? Okay, no question. And then we can now find the standard deviation. Okay, we can now find the standard deviation. So mean deviation, let's write it somewhere on top here. So mean deviation is just going to be equals to 13.75. Okay, so from this mean deviation, we can now find the standard deviation. Okay, so the standard deviation is given by this formula. So SD is equals to the square root of the summation of xi minus x bar, which is the mean, squared, then divided by n minus 1. Okay, so what we need to find here is just the summation of xi minus x bar. So we already have xi minus x bar, which is in this second row here. So we just have to find the square of it. So the square of it will just be square in this 30, minus 30, we square it, and then we put somewhere down there. So let's find, let's put a row down here. Okay, so that row, we are going to put what's happening to this pen? Okay, so that row, we're going to put xi minus x bar and then squared like that. Okay, so it means we are squaring these values that we have there. So what is it? 30 minus 30 squared. That will give me 900. So I'm going to put 900 there. Even there to be 900. Even here it will be 900. And then there to be minus 10 squared, which is 100. 5 squared to be 25. Here to be 25. There to be 0, 0. Here to be 25. 25. 25. Okay. And then here is going to be 100. What is 15 squared? So 15 squared is 225. And then 20 squared should be 400. Yeah, so 20 squared is 400. Even there to be 400. And then there to be 900. Okay, so that is what we have as our values for the xi minus x squared. So we need to find its summation. So its summation, we just have to add this plus this plus this plus this until we reach there. So we're going to say 900 plus 900 plus 900 plus 100 plus 25 plus 25 plus 0 plus 0 plus 25. Okay, plus 25 plus 25 plus another 25, and then plus 100 plus 20 plus 225, and then plus 400 plus 400, and then plus 900 like that. So what we're going to, I'm getting there is this value. Okay, I'm getting, this will be the square root of, so the summation of this is giving me 4,950 divided by, what is n? N is 16. So 16 minus 1, it is just what? 15. So it means my standard deviation will just be equals to, okay? So this 4,950 divided by 15, it is giving me 330 like that. So this is going to be equals to the square root of 330, which will just be 18.16590212. So we can round this off to three significant figures. We're going to say our SD is just going to be equals to 18.2. Okay, so that's how we find the standard deviation. If you have any questions, you can ask. Okay, so if there are no questions, let's find the coefficient of friction, the coefficient of variation now. So the coefficient of variation, we're going to use the mean and the standard deviation. So coefficient of variation is equals to the standard deviation divided by the mean, then multiplied by 100. So this is the formula. So we're going to say this is equals to, the standard deviation is 18.2 and the mean is 70 and then multiplied by 100. So what are we going to get as our coefficient of variation? I'm going to say 18.2 divided by 70. Okay, so 18.2 divided by 70 and then multiplied by 100. Okay, so I'm finding 26%. So this 26% here will be our coefficient of what? Variation. Okay, so any questions there? Okay, so if there are no questions, we are done with question 2. Let's solve question 3, which is very easy. So on question 3 there, they're saying that if the arithmetic mean of 20 values is 10, find the sum of these values. So mean is equals to the sum of the xi's divided by n. Okay, so what we've been given here, they're saying the arithmetic mean of 20 values. So it means my n is 20. And then the mean is what? 10. So find the summation of the values there. So this is going to be 10 is equals to summation of xi divided by 20. Then here we'll just cross multiply. So summation of xi, okay, summation of xi will just be equals to 10 times 20, which will give me 200. Okay, so 200 is the summation there. So question 3 is very simple. We go to question 4. Okay, question 4. So question 4, we're given a table of values. So they're saying a sample of 50 students of a class obtained the following marks out of 100 in a statistics examination. So these are the marks for the 50 students. Okay. So the first question is saying calculate the mean and the standard deviation. 2, construct a frequency distribution diagram, okay, to represent the data using the following classes. Okay, and then from there, they're saying find each of the following using the information in B above. Okay, so here, this data, we need to group it. Okay, so you can't find the mean and the standard deviation without, first of all, grouping the data. Okay, so what we are going to do here is the first step, we're first going to construct, okay, the frequency distribution using these classes. And then from there, that's when we can calculate the mean and the standard deviation, the first, second, third quartiles, and these percentiles here. So we have the 60th percentile, 48th percentile, and the 99th percentile. All right, so this is the data that we have. So we need to come up with the frequency table. 1, we solved 2, 3, 4. So we're remaining with question 5 and question 6. All right, so we are going to solve this in the next lesson.